Alright guys, welcome back to Underground Science, and in this video we'll be talking about the intrinsic capability or the internal pacemaker of the heart. Alright, so when someone refers to the internal pacemaker of the heart, they're referring to mainly the sinoatrial node. Alright, the sinoatrial node, and the reason why I'm underlining this is because for short it's called the SA node. Alright, and the SA node is what sets the sinus rhythm, and it's what sets the regular heart rate, right, which is in the range of about 60 to 80 beats per minute. All right, so it could, if you go to other sources, it could say about 60 to 90, right, around there, but we'll just keep it to 60 to 80. And so it sets the sinus rhythm. All right, so there's specialized nodal cells that we have in our SA node, and we'll look at more nodes right now. So let's go and point out just an approximation of where the SA node would be. All right, so the SA node is actually located in the right atrium, right? So it's actually part of the right atrium, and so this is going to be the SA node. It's going to be the main part of the internal pacemaker of the heart. All right, so the heart beats on its own. Now there are extrinsic factors that can affect the heart rate of the heart, the cardiac output of the heart, the blood pressure of the heart, or not the blood pressure of the heart, but the blood pressure of the whole body because of the increased cardiac output, right? Due to extrinsic innervation like adrenaline, right? Like a fight or flight response that you see when your heart starts beating like crap. All right, so that's the SA node. Then what happens is that the next question comes to mind. I said, okay, well, the SA node, the nodal cells of the heart, are responsible for pretty much transmitting their positive ions, right, throughout other nodal cells and into the muscle, into the myocardium of the heart, right, into the myocytes of the heart, right. And so remember, most of the blood naturally flows down from the atria to the ventricles, right, during ventricle diastole. But we know that there's about 20 to 30% of the blood that flows down is because of the myocardium that's around the atria also, right, that have to receive signals from some nodal cell, right, electric signals to contract, right, especially for the thick myocardium in the ventricles, and especially the left ventricle, right, because the left ventricle has to generate a lot of strength, right, the myocytes to contract the blood all over into the whole body. So the sinus rhythm is set at the SA node, the sinoatrial node, and the question is, how does it, because it's just this specific spot, right? So how does it supply all of the rest of the right atrium? All right, how does it supply the rest of the right atrium? And also, what about the left atrium? Well, it turns out that the sinoatrial node sends out electric signals, right, through and into, right, so behind this and into the left atrium also, all right, to specific nerve fibers, right, called the Bachmann's bundle. All right, so the Bachmann's bundle is spread out throughout the left atrium, and there's specialized nerve fibers that take these electrical signals, and also we'll come back to that in just a second, but the rest, there's special nerve fibers also that are in the right atrium that the sinoatrial node sends electrical signals down to the rest of the right atrium, and these specific nerve fibers are called the internodal pathways. So what happens is all of the electricity generated here travels through the Bachmann's bundle, and what happens is that the electricity travels through the Bachmann's bundle in the left atrium, and it also sends signals down to the other parts of the right atrium, and they all join into a particular nodal cell bundle, all right, called the AV node. All right, so the AV node is located also in the right atrium, where it's present right about here. And so if you see that all of these electrical signals in the Bachmann's bundle, right, eventually tell the atria to contract and squeeze the blood down to the ventricles, and then all these electrical signals meet up at the AV node of the heart. All right, so these are the Bachmann's bundle specialized nerve fibers or nerve tracts that are responsible for, or that are in the inner wall of the left atrium, that are responsible for distributing the electric signals along the myocytes of the left atrium, and then bringing those electrical signals so it can all meet up at the atrioventricular node, where we'll see what happens later. All right, so these are the Bachmann's bundle. All right, so the Bachmann's bundle. So the Bachmann's bundle does that, and now we have the internodal pathways right here. So these are called the internodal pathways. All right, and so all these will bring the electrical signals down to the atrioventricular node. Remember, the internodal pathways will distribute the signals along the myocytes of the right atrium, and then we'll bring all those signals, all of these signals, those electrical signals, will come down and meet at the atrioventricular node. The atrioventricular, so let's go and write this down. So this is going to be called the atrioventricular node, another type of specialized nodal cells, all right, with gap junctions and all that. So these are going to be our AV node, are also called our atrioventricular node. All right, so atrioventricular node. So you can see that the atrioventricular node is located between your atria, or between your right atrium and your right ventricle. All right, now what happens is that the atrioventricular node will delay the processing, so it's going to delay just a very, very short period of time so that we don't contract the ventricles and the atria at the same time, all right, because we don't want that. So we're going to delay just a little bit, so a very short period of time, all right, so very little amount of time, all right, so very little amount of time. Okay, so we're going to delay a very little amount of time, the atrioventricular node is, then it's going to send its electrical signals down to a specialized myocytes, all right, specialized heart muscle cells that can receive electrical signals and send it down even more. And these specialized myocytes that will receive these electrical signals are going to be called the bundle of His. All right, guys, so where's the bundle of His? Well, the bundle of His is located right here near the intraventricular, or you could say a little bit inside the intraventricular septum. All right. So this is another, remember, it's a specialized, they're specialized myocytes that can receive electrical signals from the atrioventricular node, and they're going to receive those action potentials, and they're going to shoot it down the bundle branches, and then the bundle branches are going to communicate with the myocytes of the ventricles and the Purkinje fibers, and all of that together is going to help the ventricles contract and send blood throughout either through the pulmonary circulation, right, through the pulmonary arteries, or either in systemic circulation through the aorta and through the brachiocephalic trunk, the common carotid, the left common carotid, and left subclavian. All right, so let's go and label this out. So this is the bundle of His. Bundle of His. All right, so it's pretty much just you're passing action potentials down in order to reach our final goal, which is to contract the myocardium. Now the bundle of His will send their action potentials down the bundle branches of the heart. So that we have left bundle branches and right bundle branches. So let me go and draw that out. And let's say blue. All right, so actually no, we have blue over there too. So let's just go and draw it out in green, all right? So the bundle branches are located all throughout, like nerve fibers, all right, that will receive the action potentials from the bundle of His and will branch into our right bundle branch. So this is our right bundle branches. Right bundle branch, and our left bundle branch. All right, so our left bundle branch. Okay, so again, our Bachmann's bundle, our bundle of His will send down its electrical signals, its action potentials to our right bundle branch, left bundle branch. The right and left bundle branches will help the myocytes of the ventricles to contract, along with the fact that the right and left bundle branches pass their action potentials down to the Purkinje fibers. All right, and the Purkinje fibers are the final way of helping the ventricles contract as a whole and in a more accurate fashion. All right, so the Purkinje fibers are actually scattered throughout the whole myocardium of the ventricles. All right, and so now the right and left bundle branches will then finally, so I'm going to label this right here, finally send its action potentials down to the Purkinje fibers, which will finally help squeeze and contract the myocardium of the ventricles and squeeze that blood either through the systemic circulation or pulmonary circulation. All right, so these are our Purkinje fibers. And that's it. That's the electrical conduction system, the intrinsic conduction system of the heart, right? This happens by itself. And it's all connected through gap junctions and everything. So gap junctions are pretty much they're just channels that connect the heart. They connect the heart, the nodal cells of the heart together, and the nodal cells can be connected to the myocytes of the heart together through gap junctions and desmosomes. And the gap junctions allow ions to pass straight from either a nodal cell to another nodal cell or a nodal cell to a myocyte. And it's actually pretty cool because all the heart muscle cells contract at once, right? So both the ventricular myocytes will contract at once, right? So both ventricles contract at once, sending blood to the systemic this way and pulmonary, or we can see that the atria will contract at once, sending the blood down to the ventricles. However, most of the blood that goes down to the ventricles during ventricular diastole, so the relaxation and filling of the ventricles, most of the blood that goes down is just because of natural filling, all right? That it'll just go down because of the force of gravity, all right? But the atria have to contract, though, just a little bit in order to push some of that blood down to the ventricles. All right, so that's pretty much it. That's what I want to get through with you when we're talking about the internal pacemaker of the heart. I hope this video wasn't too messy or boring. I hope you guys tune into my future videos. We'll talk about more cool topics about biochem, physics, and chem. And so see you guys later. Stay safe, and don't forget to hit that notification bell, like, and subscribe. All right, so see you guys next time.